So the one bummer thing about this one is that it's not going to equal 10 pi over 7. You don't get a freebie on that. Why not? Because the range of the inverse sine is going to be between negative pi over 2 and pi over 2. And since this doesn't fall in that range, these just don't quite cancel out evenly. So let's think about sine of 10 pi over 7 and figure out where 10 pi over 7 has to be as an angle. Now I'm just going to write it as 10 over 7 times pi to try and pin down where this angle is. Now 10 over 7 has to be bigger than 1, right? So this is between pi, and it's less than this. What's 14 divided by 7 reduced to?
2.
Reduces to 2. Good. So our angle is somewhere down here. And if it helps, you can kind of figure out exactly where by converting this to degrees. What do you think? Do I want to do that? Maybe it wouldn't hurt to convert that to degrees and just look about where that angle is. So if I convert this to degrees, 10 over 7 times pi times 180 over pi, that'll cancel. I'll get 1800 divided by 7, 1800 divided by 7, 257 degrees. Okay, so what quadrant does that put it in? Where's that going to be? That's going to be in the third quadrant someplace. So let's just draw an angle, not exactly at random, but a little bit at random. It doesn't have to be terribly precise here. So this is our angle, 10 pi over 7. Now what we want is, or what we're going to get from this, when we take the sine of this, what coordinate are we going to get? We're going to get the x or y coordinate.
The y.
The y coordinate. Good. So there's another place on the unit circle with the same y coordinate, and it's over here. So, okay. Now, I guess I got to figure out what this angle is here between the negative x-axis and here, because that angle and this angle are going to be the same. So if I can figure out what this is, then I could just get to the same y coordinate by going the negative direction. Does that plan make sense?
A little bit.
So what we're trying to do, when you take the sine of something, you're going to get the y coordinate. And then I want the inverse sine of something, but the inverse sine of that something is going to give me an angle between 0, it's going to be negative pi over 2 and pi over 2. When I take the inverse sine, I'm going to get an angle here. So I need to find something in the range of negative pi over 2 to pi over 2 that has this y coordinate. So I got to go a negative angle instead of what I started out with, which is this positive angle. Here's 10 pi over 7. It brings me down to this y coordinate in quadrant 3. I need to find a fourth quadrant angle that has the same y coordinate. So my game plan is to figure out, well, what's this little angle right here? If I can figure out that much, then I could start out at 0 and go that negative angle, and I'd be all set. Is that helping out a little bit more?
Yes.
Okay, good. So what's this angle halfway around in radians? Remember what that one's called?
Pi.
Pi. So I want to know how far past pi is this angle. So I can do 10 pi over 7 minus pi. And because these don't have a common denominator, let me rewrite that as 10 pi over 7 minus 7 pi over 7, which gives me 3 pi over 7. So that's this little piece right here, 3 pi over 7. So what do you think the answer is then overall? What would I have?
Negative 3 pi over 7.
Negative 3 pi over 7. That's it. And so that'll take you this negative direction, and it'll give you the same y coordinate that this one would.
Thank you.
You're most welcome. Thank you.